Hello and welcome to the video. This video is about my embedded systems internship which I did under Emergency Institute. My name is Aaron Lakra and I'm currently pursuing my BTech in computer engineering from Karunya Institute of Technology and Sciences, and the title of the project is microwave oven simulation under using the PIC16 F877A microcontroller. So the topics which were covered during the internship are: first we started with the basics of C programming, which we learned about all the C programming basics which we need to code the project with. Then, for example, the conditional statements, the if statement, the while loop, the for loop. And then we moved on to the basics of embedded C programming, and then we learned about the different data structures, for example, arrays and pointers to functions, and then we learned about functions and strings, and then we moved on to learn about embedded systems in general, and we learned about the different types of embedded systems, and in that we also learned about microcontrollers and microprocessors and the differences between them. And then we learned about the PIC16 F877A microcontroller which we'll be using for our project. And then we learned about the different peripherals that we'll be using with the PIC16 F877A microcontroller and how to program them. And then we moved on to learn how we'll integrate all those things together and how we'll interface all the peripherals with the microcontroller and how to program them and how to get them working together. So now we'll see about more about the topic. So the topic is to simulate a microwave oven in the Pixem Lab simulator. And as we know, the microwave oven is used to heat and cook food. So the modes in the microwave oven which are in the real world, we have incorporated those in our simulation project. The first one is the micro mode, which is for the traditional oven mode. The second is the grill mode, used to cook meat and bread. Third is the convection mode. In convection mode, the oven is preheated and the food is cooked later after the oven is preheated using a timer. And the fourth one is a start mode. So what the start mode does is basically it heats the food just for about 30 seconds and it does not need any temperature settings or time settings. So we learned about embedded systems in general. So an embedded system is basically a type of system which has a specific function, a specific role to do, and it is a combination of both software and hardware. An embedded system does not only consist of software or does not only consist of hardware. It is a combination of both software and hardware, and it uses peripherals also to take in value from the environment around it and uses it to the process the inputs and gives the values and acts according to what it has been programmed to do. So now we'll see about the types of embedded systems we learned during the internship. The first one is the real-time system. So a real-time embedded system, what it does is it acts accordingly to the real-time values or inputs that it has been receiving up till now. So even in the real-time system, there are two types of systems. The first is a soft real-time embedded system. A soft real-time embedded system can tolerate a deadline that has been given to it, but the other type of embedded system which comes under the real-time system cannot avoid the deadline that it has been given. If the deadline is avoided in a hard real-time embedded system, it can cause harm to a human life, or it can cause heavy damage to capital, or can result in loss of money. Examples are the military usage in defense sector or medical usage in the health sector. A second type of embedded system is the standalone embedded system, which are basically independent embedded systems which can work by themselves and they do not need a host system. So they need not network with other embedded systems for it to get the work done. For example, a calculator, and another example can be a microwave oven, uh, which we are building as a project now. So the third type of embedded system is a networked system. So a networked system is basically multiple embedded systems which coordinate with each other and take in values from other embedded systems also, and work with those values, and try to get the work done. They basically communicate over a network or a web server. Example for a networked embedded system is a ATM machine and also a home security system. The fourth type of embedded system that we learnt about is a mobile embedded system. Which a mobile embedded system is basically a portable embedded system which is easy to use and is very small compared to other embedded systems. So now we'll move on to see the requirements for the project. The first requirement is the MP Lab IDE, the Integrated Development Environment, which we'll need to code our project in. We'll use C programming to code our project, and for that IDE also we need a compiler, namely the XC8 compiler, which will help convert our code and help compile it. And then we'll use the Pixim Lab simulator, and the Pixim Lab simulator has various modules under it, and with that it also has various microcontrollers which we can use, and we'll use mainly the PIC16 F877A microcontroller for the project. Then we need a 6 into 4 CLCD display which will display all the information we need for the project and to act according to it. And then we'll need a tactile switch, and then we'll need a MKP, which is basically a matrix keypad through which we'll input all the values needed for the project. And then we'll need a timer for us, for the embedded system to coordinate with the real-time clock in the real world. So now we'll see the components used in this project. The first component is a matrix keypad. So a matrix keypad is basically a set of push buttons or switches which are arranged in a matrix format, basically format of frozen columns. So these are the buttons which we'll use in a simulation that will take the input for our project. And the second component is the character liquid crystal display, namely in short CLCD, which will show all the information for our project. And where there are two types of display in the Pixim Lab simulator. The first is a 16 into 2 display, the second is the 16 into 4 display, and we'll be using the 16 into 4 display for our project. And the next component, which is basically and probably the most important component of our project, is the microcontroller itself, namely the PIC16 F877A microcontroller, which is a 40 pin PIC microcontroller manufactured by the company Microchip, and is designed using the RISC architecture and is used in various embedded projects. It has 5 ports on it, namely port A, port B, port C, port D, and port E. And it has 3 timers in it uh, for the functions to perform, and 2 of which are 8-bit timers and one of them is a 16-bit timer. Speaking of timers, we'll jump on the concept of timers. So timers are very important in any embedded system. So what a timer does is It coordinates the embedded system's time with the clock that we have in real time. These are also used as reference signal generators, and these are used to measure specific time intervals also. So now we'll move on to the project demo, and then we'll open the Pixim Lab simulator. We'll reload our project. It's powering on. So in the microwave oven simulation project, we have four modes. The first mode, as we can see, yeah, as we can see, the first mode is the microwave mode. The second mode is the grill mode. The third one is the convection mode. The fourth one is the start mode. So now we'll use the matrix keypad and we'll press the number 1, and we'll go to the micro mode. We'll reload our project. Now we'll press the number 1 in the keypad. Yeah, so now it's working. So the power in default is set as 900 watts for the traditional microwave oven, and then we'll need to set the time. So we'll use the matrix keypad and we'll give the time as 20 seconds, and then we'll use the hash button to enter the value. So now the oven has started and it is on microwave mode, and it will run for 20 seconds and it will heat the food. Yeah, so the microwave mode operation is done. So now we'll go to the grill mode in the microwave oven. We press the number 2. Yeah, we'll set the time as 10 seconds, 1 and 0, and then we'll enter using the hash button. So it'll run the grill mode for 10 seconds. So the grill mode function has been completed, and then we'll move on to the convection mode. So we have set the threshold or limit value for the convection mode as 180 degrees Celsius. So now we'll check if the function is working. We'll try entering 200 degrees Celsius as the value, and then we'll check if it is taking the input or not. So as we can see, it is saying that the temperature we gave is invalid. Then we'll again go to the convection mode, then we'll set the temperature as 150 degrees Celsius, and now it will run. Yeah, so it is running in 150 degrees Celsius for about 180 seconds, which we set. And then so now we'll see the fourth option and we'll press the reset button. It will take a long time. 170 seconds. So now we'll press the reset button and it'll reset our microwave oven. So now we'll see the fourth option, which is the start option, which is basically there for heating the food for 30 seconds, which does not need any temperature setting, which does not need any time setting. So now we'll check the start option, which is, we'll press the number 4 in the matrix keypad. So as you can see, the microwave oven has started heating our food for 30 seconds. So all the four modes or functions have been completed, and this is it for the video for the embedded systems internship. Thank you.